Number 2 then, from the 2006 Higher Maths Paper 1, equation of a circle. They've given a diagram and it simply says, what's the equation of the circle in this diagram for part A? 2 marks. Well, you're looking for the equation of a circle, so put down that general form for the equation of a circle. Well, when I say the general form you would use to find it, which is the x minus a squared y minus b all squared equals r squared. Exactly the same thing you would do if you're looking for the equation of a line. Well, obviously it would be a different equation for a line, but notice how it's got this same form of the y minus b and the x minus a. That's because these are displaced equations. The basic equation of a circle of radius r and centred at the origin is x squared plus y squared equals r squared. If the centre of the circle isn't at the origin, but was at some other point, call that point AB, then you can turn it back into this simple form simply by translating. Not so much translating the circle, but translating the axis. You could do a change of axis. If you move the axis up so that you create new y and x coordinates, it should go back to just x squared and y squared equals r squared. And to do that, you'd have to move it along the way by the amount a for the x coordinate. So that means as you move it along, you'll be subtracting the amount a from the x coordinate. So that becomes x minus a squared. And then move it up, just now it's b up in the y direction. As you move this axis up by the amount b, you'll be subtracting that until the difference is 0. So y minus b equals r squared. It's the displaced equation of the circle. That's the basic circle. The same happens with a line, and the same happens with a parabola. Line. The basic equation of a line that passes through the origin is y equals mx, where m's the gradient, distance up over distance along. If the line doesn't pass through the origin, say I pick a point on the line AB. If a line doesn't pass through the origin, I can recreate this simple basic equation by changing the coordinates, by shifting the origin. If I shift it the same as before, if I shift it along A and then shift it up B, I've got a line going through the origin again. If you shift it along A, you'll be taking A off of the x coordinates. All the x coordinates are getting smaller until they become 0 there for that point. And if you shift it up B, you'll be taking B off the y coordinate. So it becomes y minus b equals mx minus a. It's the shifted equation, the shifted basic equation. Same for the parabola. The basic parabola that goes through the origin has got the equation y equals x squared. Or, altering its width if you like, you could say some multiple of x squared. But if the turning point doesn't go through the origin, if the turning point was at some point AB, so the parabola looked like this for instance, you could recreate that equation by shifting the axis. Move it along A, move it up B, and there it is through the origin again. Except in order to move it along, you've had to take A off of the x coordinate and B off of the y coordinate. So once again, you've got y minus b is k times x minus a squared. The y, you've subtracted b, and for the x, you've subtracted a. But you probably know that better in the form of y equals some multiple of x minus a squared plus b. And then you remember, oh yes, that's the turning point. Still, that makes this very easy then. For the first 2 marks, what's the equation of the circle? Use this one by preference, because those will be the coordinates of the centre, and that's the radius, obviously. And again, like with the line, it's sufficient just to insert those numbers into the equation and you get the mark. So the centre's at negative 2, 3. So if I say that's going to be x take away the x coordinate squared and y take away the y coordinate squared, that'll be the first mark. Not even needing to make that x plus 2, which you would do afterwards anyway. Now that means I need this radius. The radius is the distance from the centre to any point in the circumference. Well, I know these 2 points, so it's just Pythagoras. And in this case, for this question, working out this length is going to be worth about 4 out of the 6 marks, effectively, in the construction you're about to make. Because to find that length, you're going to use Pythagoras, which involves this little right-angled triangle here, where you've got the horizontal length from -2 to 1 of 3, and the vertical length from 3 to 6 of 3. That little triangle is going to be worth 4 marks. Because straight away I can work out the radius. I'll just do it down here. The radius will equal CP. Now notice it's not actually the radius that I want. If the question had said what's the radius, then I would have gone through Pythagoras with the square root. But since it says what's the radius squared, well, that's perfect for the radius. Because the radius squared is going to be the difference in the x coordinate squared. I'll just write it down that way to begin with. And then the difference in the y coordinate squared. But you can go straight in with those numbers. That's a 3 squared and a 3 squared, which means the radius squared is going to be 9 and 9, which is 18. And putting that 18 in gives you the second mark. Now, looking at the marking scheme, whereas it's quite acceptable to slot in these numbers, even if it leaves a takeaway here, it's not acceptable to slot in the radius here in the form of, because if the radius squared is 18, that means the radius is actually root 18. And you wouldn't get the mark for part A, for this half of it, if you rewrote that as this equals root 18 squared. You'd have to tidy that back up to 18 for the radius squared. Still, I wouldn't leave it like that. I would finish that off and say x plus, 2 squared, y minus 3 squared equals 18 for the equation of the circle. Whereas it's sufficient just to leave it like x take away -2. Now, whenever you're asked to find the equation of a line, the equation of a circle, the equation of a parabola, you're always best to go for this form of it. You know, that translated form, the shifted form of the basic equation. You could still get the 2 marks here if you went for the expanded form, which is sometimes called the general form. If you put down x squared plus y squared plus, and then that 2gx plus 2fy plus c equals 0. You could still get your 2 marks if you filled this in. But that means you'd have to interpret these 3 parts. Remember, that is just this thing multiplied out. Obviously, when you square a bracket, it'll be square the first, square the last, twice the product. You would have an x squared plus an a squared, and then a minus 2ax. So all that's happened to a, which is the x coordinate of the centre, it's been multiplied by -2. The only difference with this form from this form, let's notice this form doesn't go x squared and y squared minus 2ax minus 2by plus c equals 0, which it could, it's gone for positives. It's just that those have got the opposite signs. You know the coordinates have been doubled. If you want the coordinates of the centre, you would just half these numbers and make them negative. It's just more confusing, I think, to use this form of it to try and get the equation of the circle than just to plop the numbers straight into that translated form. So in here then, this 2g is going to be double, not the coordinate, but the negative of the coordinate. It'll be double the negative of -2. So that's double 2, which is a 4. And 2f is going to be double the y coordinate, but double the negative of the y coordinate. So that's going to be -6. Then for the c, the simplest way of doing that would just be by putting in any point in the circle, rather than messing about with that r squared equals f squared plus g squared minus c business, and then rearranging that for c. You can see it's actually quite a mess to try and use this one. That's a much simpler one. So to finish that off there, that would be x squared plus y squared plus 4x minus 6y plus c equals 0. Then either work out c by working out the radius, which you probably need to know anyway later on, and then subtracting the squares of those 2 numbers, or simply say the 0.16 should fit this equation. 1/6 should fit this. So if you put 1 for x and 6 for y, 1 for x and 6 for y, that lot should come to 0. Well, that's 36 minus 36. That's 1 plus 4 is 5. Take the 5 across, so c is negative 5. Then you can finish it off. X squared plus y squared plus 4x minus 6y minus 5 equals 0 for your 2 marks. The first mark for those two, and the second mark for getting C. Much messier. Don't do it. Use the shifted equation. Part B. PQ is a diameter. Find the equation of the tangent to this diameter at Q. So this is the line I want. The line that's at right angles to the diameter. You're looking for the equation of a line, so you'll be using y minus b equals mx minus a. That finded equation, that translated equation. And to use this, I need a point on it, so that'll be the point Q, and its gradient. So I'll need to find Q, and to find its gradient, since a tangent is at right angles to a radius or diameter, that means I want the gradient of this diameter, or just the gradient of the radius. And that's where this little handy triangle pops back in again. Because to get the gradient of this line, I need the distance along and the distance up from one point to another. To get the gradient of CP, I need the distance up over the distance along between any 2 points, and I've already done that. The distance up was 3, and the distance along was 3. That meant the gradient of CP is 1. Now that's 1 mark. That means that the gradient of the tangent will be the negative of the reciprocal. You can put down the reason if you like, but there's only 1 mark for the answer. It's the negative of the reciprocal of the gradient, put that in if you wish, which means turn it upside down and make it negative. So that will be negative 1. That's another mark. Now I need the point on it. What's Q? Now, curiously in this question, Q is indicated as being on the x-axis, which normally means that I'm going to substitute that into some equation and find the x-coordinate, because if it's on the x-axis, that means the y-coordinate is 0. But that would be a much lengthier way of doing it. And nowhere does it actually mention in this question that Q is on the x-axis, though it shows it with a great big blob there. There it is on the x-axis. No, the simplest way to find Q is by this big line pointing to it. To get to point Q from C, I would do the same thing as to get from P to C. I know the move it takes to get from P to C. I know that displacement. I know that PC, I'll put it down here. I know that to go from P to C, I would go 3 back and 3 down. Negative 3, negative 3. Remember, that's a vector there. It's a displacement. It's a movement from one point to another. A displacement from one place to another. I go back 3, down 3. So if from P to C is back 3, down 3, from C to Q must be the same. So that means going from C to Q is the same as going from P to C. It's back 3, down 3. Which means you can find Q simply by taking 3 off of the x-coordinate and 3 off of the y-coordinate. I could write down a little displacement equation. I could say that to get to the point Q, I would start at the point C and follow the path CQ. To get to the point Q, I don't know where it is, I'll start at the origin and go to a point I do know. I do know how to get to C. I know that route, and I know how to get to C from C to Q. I know that route. So following these 2 routes will take me straight to Q. That would be the vector equation. But you could just state it straight away, because you know what that means. That's the x component, that's the y component. That says take 3 off the x coordinate. So it would be negative 2, take away 3, and take 3 off the y coordinate. 3, take away 3. There's the 2 parts there. Which means that Q is the point, negative 5, 0. Now again, there's only 1 mark for this, so that mark has to be for the answer. So I don't need to show these parts particularly, but I think it should certainly show this bit to begin with. That's how I did it. I used displacements. I just followed the line. I followed this line that pointed the way to Q. And then the final part for the 4 marks is just to slot it back into this. So back to here we go. Y minus the y coordinate of the point is the gradient, -1, times x minus the x coordinate of the point, -5. And according to the marking scheme, that's it for that final 4th mark, leaving it in that form. But you can't resist tidying it up, especially when you've got this y take away 0. Y equals -x, and then this part's going to be with the 3 negatives there, -5. I always feel it's best to put it into the form of y equals mx plus c if there's no fractions, because it's the most useful form of an equation when you're going to use it later on. So there's no marks for that. The marks come simply at the point where you substituted in those 3 numbers. Now, for point Q, because it did indicate, if it was a different question and you didn't have any indication of how to get to point Q, if those other lines weren't there, and it was just, here's a circle, here's its equation, here's point Q in the x-axis, you could have found Q by substituting into its equation. So you could have, but you wouldn't have, done this. You could have said, well, here's my equation. X plus 2 squared plus y minus 3 squared equals 18. The point Q lies in the x-axis, so that I know for the point Q, its y coordinate is 0. It's something 0. So putting that into this, I've got x plus 2 squared plus, and if y is 0, that's -3 squared is 18. And then solve that to find x. Remember, of course, this point, if its y coordinate is 0, there's 2 points with a y coordinate of 0. So you'll have to pick the one on the left according to the diagram. And then to solve that, you don't need to rearrange that into a quadratic. There's only one mention of x. You can simply peel away the things that are operating on it. Peel away the operations. So that x plus 2 squared, that plus 9, take it away, will leave you with a 9. Remove the squaring, means that x squared will be the square root, but it could be a positive or negative the square root of that. So that's plus or minus the square root of 9, it's plus or minus 3. And then finally remove the addition of 2, so that'll be -2 plus or minus that 3. That gives you 2 values of x. -2 take away 3, or -2 plus 3. So you've got -5 or 1. So in this case, you know that it's the one on the left, which means that Q is going to be the point -5, and of course y was 0, because it was the point on the left. But you wouldn't do all of this when you've got this line pointing straight to it and you've already established the movements 3, 3. So question 2 then, 6 marks altogether.